Now, let's dive into the exciting world of Swift programming language. If you're ready to learn, buckle up. Swift is powerful, intuitive, and an essential language for iOS development. Today, we will explore how Swift handles simple values and types, really setting the foundation for your programming journey. So far, we've laid down the foundational steps for iOS development, like installing Xcode and creating a new project with an app interface using Storyboard. We emphasize the importance of testing on actual iOS devices for accurate performance insights. And we discussed how to prepare the app for deployment. Remember that managing code signing and permissions via the info.plist file is key. Plus, we dove into debugging tools and techniques for optimizing performance, ensuring a seamless user experience through real-world testing of UI interactions and those hardware-dependent features. And we can't forget, we highlighted the necessity of thorough testing, which enhances user satisfaction and the overall quality of the app. Now, let's pivot to the core aspects of the Swift language, focusing on its values and types. Now, let's explore how to define an integer variable in Swift. In this example, we'll declare a variable named age, and it's of type int. We're assigning it the value of 25. Now, this straightforward declaration really highlights the importance of type safety in Swift. By specifying the type as int, we're ensuring that this variable can only hold integer values. And why is that important? Well, it helps prevent unintended errors. Imagine trying to assign a string like 25 to age. Swift would actually stop you and raise a compile time error instead. This feature of Swift not only helps maintain the integrity of your data, but also aids in debugging, as these rules around types are enforced at compile time. As you continue your journey in Swift, you'll find that such constraints enable you to write more secure and reliable code, letting you focus on other parts of your application logic without worrying about accidental type mismatches. So you see, it's all about creating a robust foundation for your programming efforts. Now, let's dive into the world of floating point numbers in Swift, which are essential for representing decimal values. Here's how we can implement this. We start by defining a variable called pi using a type of double. This allows us to store a more precise representation of pi, approximately 3.1415. The use of double is crucial in scenarios where accuracy is paramount, like scientific calculations. Next, we introduce another variable named temperature, but this time we opt for the float type. Now, why float? Well, the float type consumes less memory than double, which makes it perfect for storing values like temperature that don't need as high precision. This distinction between double and float is particularly important when choosing the right type for your application's requirements. It's a key consideration in programming, especially for tasks related to scientific and graphic computations. By understanding these types, you're better equipped to handle data accurately and effectively in your Swift applications. The figure titled Fundamental Data Types in Swift displays a bar chart that quantifies the relative importance of 4 core Swift types: int, which holds 25%, double at a prominent 35%, string at 30%, and bool, the smallest, at 10%. Each data type appears on the x-axis, while the y-axis shows corresponding importance percentages with numeric labels above each bar. Now, if we take a look at the chart, we see that double is really the standout here, clearly emphasizing the focus on floating point precision and numerical computations. Coming in right behind it is string at 30%, which underscores just how vital text handling is in most Swift tasks. Int, while at 25%, shows that whole number arithmetic continues to play an important role, just a tad less dominant than its floating point and string counterparts. And then there's bool at 10%, indicating that while logical conditions are indeed necessary for programming, they occupy a smaller portion of this overall importance picture. From these proportions, we can conclude that when we combine the numeric types, int and double together, along with string, we actually hit a whopping total of 90%. This suggests that our instruction should really focus on numeric precision and string manipulation first and foremost, with double and string being the primary concepts, followed by int, while Boolean logic serves as a supportive topic, although less central. So there you have it. Now, let's explore how we can handle strings in Swift, which are fundamental for displaying and manipulating text in our applications. We start by declaring a variable named greeting that stores a simple string message, "Hello Swift." This demonstrates how easy it is to create and assign string values in Swift. Next, we'll write another variable, name, assigned with Alice representing a user's name. To craft a personalized message, we now implement string concatenation by creating a variable called welcome message. This variable combines both greeting and name using the addition operator. Additionally, we utilize string interpolation to seamlessly embed the name within the welcome message. This clever technique allows us to create dynamic and user-friendly output, resulting in a message that reads, "Hello Swift, my name is Alice." This showcases how Swift string manipulation features, particularly concatenation and interpolation, make it super easy to produce interactive and engaging text outputs in your applications. Now, let's take a closer look at how to work with Boolean values in Swift, which are really fundamental for controlling the flow of your program. In our code, we'll start by declaring a Boolean variable named isSwiftFun and assign it to value true. This declaration signifies that we're defining a state that can either represent something as true or false. Next, we'll implement a simple conditional statement using an if statement. The if checks whether isSwiftFun evaluates to true. If it does, Swift executes the block of code that prints "Swift is indeed fun." This really demonstrates how the condition dynamically influences the output based on the Boolean value we set earlier. Now, if isSwiftFun were false instead, the else block would execute, prompting us with "Let's make Swift fun." This execution flow highlights the power of Booleans in making decisions within your code, allowing for a more interactive and responsive user experience. Understanding how to utilize Booleans effectively is crucial for writing logical conditions that steer your application's behavior. Now that we've got a grasp on Swift's fundamental types, let's dive into how type inference simplifies our coding experience. Here, we're going to implement a variable named message and assign it the string "type inference is cool." Now, notice something interesting. We haven't explicitly defined the type of this variable. Instead, Swift automatically infers that message is of type string just based on the value assigned to it. This is such a great illustration of Swift's type inference feature, which really enhances readability by cutting down on redundancy in our code. Thanks to type inference, you can focus more on writing meaningful code without getting bogged down by specifying types for every variable. I mean, this approach helps maintain type safety while allowing for a cleaner coding style. By letting the Swift compiler deduce the variable type from the assigned value, developers can write more concise and clear code without sacrificing safety. So, understanding and leveraging type inference is crucial here, as it streamlines the development process and makes our Swift code more elegant and efficient. Now, let's take a look at how we can use constants in Swift to enhance our code's reliability. In Swift, constants are defined using the let keyword, which creates a value that remains unchanged throughout the execution of the program. For instance, we can declare a constant called maximum login attempts and assign it the value of 3. This means that anywhere in our code, this constant will reliably represent the number of allowed login attempts, ensuring that developers do not inadvertently alter this value at runtime. This practice not only prevents potential bugs related to changing critical values, but also communicates the intent clearly to anyone reading the code. Using constants helps maintain data integrity and simplifies debugging, as the programmer can clearly see which values are meant to remain fixed. Constants are especially useful for configurations or settings that should remain constant, making your code not only more understandable, but also easier to maintain. Deep breath in, then sigh softly. Now let's take a look at how to work with arrays in Swift, which are essential for storing ordered collections of values. Thoughtful pause. To declare an array of integers, we use the syntax that specifies the type of the elements the array will hold. In this case, that's int, followed by assigning it an array of integers. This allows us to efficiently manage groups of related data, like, say, a list of numbers. Next, we're going to write some code to access specific elements from the array. We can achieve this by using the index of the element we want, keeping in mind that Swift employs zero-based indexing. So this means the first element is at index 0, the second at index 1, and so forth. In our example, to fetch and print the second number in the array, we can simply use print numbers 1. This line will output the number 2, demonstrating how easy it is to retrieve values from an array based on their position. Understanding this array access pattern is crucial because you'll frequently use it to manipulate collections of data in your applications. Next, we will look at how to use dictionaries in Swift to store and retrieve data effectively. A dictionary is a collection that holds key-value pairs, making it an excellent choice for associating identifiable keys with corresponding values. For example, we can create a dictionary named Student Grades, where each student's name serves as the key and their grade represents the value. This structure allows us easy access to a student's grade based on their name. Now, let's see how we can implement this in our code. By defining student grades, we initialize it with a few entries, such as Alice receiving an A, Bob a B, and Charlie a C. This format allows you to quickly look up any student's grade. To retrieve Bob's grade, we use the dictionary syntax student grades, parentheses, Bob. However, since the information we retrieve could potentially be absent, we incorporate the double dash operator. This operator safely unwraps the optional return value, providing a default message, not found, if Bob's entry is missing. This enhances the robustness of our application by preventing runtime crashes. This way, we ensure that our code handles errors gracefully while managing key-value data efficiently. Now, let's see how we can implement a set in Swift. A set is a unique collection of elements, which means it ensures no duplicates, making it a really valuable structure for scenarios where distinct values are essential. So, in our example, we start by declaring a set called fruitSet, which stores strings representing fruit names. Initially, we populate this set with 3 fruits: apple, banana, and orange. Now, to demonstrate the dynamic nature of sets, we can insert grapes into fruitSet using the insert method. This action ensures that grapes is added to our collection while automatically managing the uniqueness of items in the set. Finally, we utilize the count property to retrieve the number of unique items within the set, which now totals 4. It's important to note that sets do not maintain any specific order, so the printed output may display these fruits in a different sequence than they were added. This feature highlights the unordered nature of sets and showcases their usefulness for handling collections of distinct items in Swift. As we round off our introduction to Swift, let's take a moment to appreciate how these foundational values and types are crucial for diving into more sophisticated features and programming paradigms, like object-oriented programming with classes and structures. Now, grasping how to handle basic data types isn't just a minor detail, It empowers you to implement logic, process data, and effectively manage program flow. On this adventure, you're not just learning syntax, you're immersing yourself in the very language of programming. Remember, whether you're building a simple app or a complex software system, mastering these basic building blocks in Swift will really help you navigate the vast ocean of coding with a lot more confidence. So, keep practicing, explore the Swift playgrounds. Yes, and get your hands on some cool projects. Your journey is just getting started. On our next session, we're going to dive deeper into control flow statements. Yes, you heard that right, where we'll explore conditionals and loops. These are really key components that will help us make our applications dynamic and responsive. It's like giving our code a brain, allowing it to make decisions and repeat actions based on various conditions. The journey is just getting started, and trust me, it's only going to get more exciting from here.